I'd say it's fair to say that this section is easier than the previous one, but it does involve some word problems that we'll get into in the next video. But first, let's talk about, let's do another kind of thought experiment. Let's say we have that a fraction equals a fraction. So we have that a over b equals c over d. Now let's multiply both sides of this equation by the denominator of one of those fractions. So we're not concerned about lowest common denominator right now. We're just concerned about what the denominators are. So we're going to go ahead and multiply both sides of this by b. So that means we'll have, when this b goes over here, it'll cancel with this b. So we'll just have a left. And then when it goes over here, we'll have c times b over d. There's not going to be any canceling. So as it goes over here, I'll go ahead and do this over here. So as it goes to the left side, we'll have b times, oh gosh, bad handwriting, sorry, a over b, and then those b's will end up canceling out, and we'll just have a left. That's how I got this here. And then when we distribute it here, it's not going to do any canceling because there's no b on the bottom. So we've multiplied one side of the equation by the denominator. Now let's, I multiplied both sides of the equation, not one side, by the denominator of one side. Now let's multiply both sides by the denominator of the other side. So that means let's multiply both sides by d. So when it gets to the a, we're going to see that it's just equal to AD. Because there's nothing to cancel or anything, we're just multiplying both sides by a. But then when we move it over here, we're going to have the same situation we had with the b over here. So we're going to have equals, but this cb over d times d, well, the d's are going to cancel, so we'll just have cb. Whoops, that's not cb, that's db. Typo. Okay, so now if we want to think of this visually, see, look what we have here. We now no longer have any fractions. We just have AD equals CB. And if we want to think of this visually, we just moved the denominator of each side to the numerator of the other. So let's put a little bit more room there. That didn't. Okay, so in fact, let's go ahead and get rid of this middle thing here. I'm going to get rid of this here. Okay, so what we did was basically we took this denominator, moved it up here, took this denominator, moved it up here. I mean, if you want to think of it visually, that's what we did, because see, now the B is next to the C, and the D is next to the A. This is called cross-multiplying. But something that's very important to understand is that it only works if you have that a fraction equals a fraction. It does not work if you have a fraction plus a fraction equals a fraction. So if you have a over b plus c over d equals m over n, that's an ugly m, isn't it? Well, you can't cross-multiply here because you don't have a fraction equals a fraction. That's something that's pretty important to understand. So just remember that when you're cross-multiplying, you have a fraction equals a fraction. You're just moving the denominators up to the other side. So let's take a look at a specific example of this. So again, I forgot to put the examples at the beginning of the video, but I think we'll be okay. So let's say we have 3/2 equals 6 over x. So this is our example, and I'll keep this right here for now. We want to cross-multiply this. So remember what we did here is we cross-multiplied. We have this x in the denominator here, and the easiest way to get rid of that, we could solve this using the exact same methods that we used in 7.5. It works just fine. There's nothing wrong with that. But we have a slightly easier tool now for how to do that. We can cross-multiply. So we can move this x up here and this 2 up here. So that means we'll have 3x equals 2 times 6 will give us 12. So we have 3x equals 12. Now I can divide both sides by 3. And then, of course, those 3's will cancel, and we'll get that x equals 4. So that means that when we can check our answer, of course, and I think I will in just a second, but the point being now that we found an easy way to figure out what x is in this specific special case. Now, just to check it, just for the sake of it, we'll have 6 over 4. Well, you can reduce this down to 3 over 2, because we could just divide top and bottom by 2. 3 over 2 just happens to be the left side, so that means that this works, and this answer is correct. Now, cross multiplication has a lot of applications in ratios, which is what we're going to be doing in the next 2 videos. But this is the basic idea for cross multiplication. So I'll see you in the next video.